So in this video, we are going to learn how to solve for integrals of what functions using what trig substitution. Okay, so the first method we have here, okay, is with expressions of the form what square root of what a squared minus what x squared. So let's look at how we are going to do it with such expressions. So for us to do this, I'm going to draw a triangle here. This will help us understand this very easily. So this is theta here. Okay, so I'm going to take this side to be A. This side will be my side A, and then this side will be what? My side what? X. Okay, I'm going to make this side A squared minus what? X squared. Okay. So now that we have our triangle, let's look on it and then write equations for the sine, the cosine, and then the tangent of what? The angle. So that was so ka twa. Okay, so now let's first do for sine. So the sine of this angle is what? Opposite, right? Over what? Hypotenuse, that's x over what? A. And then cosine of what? This angle is what? Adjacent over what? Hypotenuse, that will be root of what? A squared minus what? X squared over hypotenuse, which is what? A. And then the tangent of what? Theta is what? Opposite over what? Adjacent, that what? X over what? Square root of what? A squared minus what? X squared. Okay, so this is what I have now. So for the first situation here, okay, where I have what? Square root of what? A squared minus what? X squared here. I'm going to consider the sine of theta and then cosine of what? Theta. Okay, so how many focus will be on sine of theta and then cosine of what? Theta. So let's look at what will happen. So from sine of theta equals x over a here, you can see that what we can make x the subject very easily. So let's do that. So I have what? Sine of theta equals what? X what over a. Right, so if I want to make x the subject, I can take a to this side. So that what? Equal to what? A sine of what? Theta equals what? X. So let me write this as x equals what? A sine of what? Theta. Okay, so now from here, what we do next is that we are going to find the derivative of what? This equation here. So that what? The x over what? The theta will equal to what? A times what? Cosine of what? Theta. Okay, so now let me explain how I got this. So we have what? X will be equal to what? A sine of what? Theta. And you know we are going to apply what the product rule here. Okay, so the x over what? The theta. First of all, you are going to maintain a, then find the derivative of what? Sine theta. So that what? A cosine of what? Theta. Then plus you are going to maintain sine of theta, then you find the derivative of a, which is a constant. So that what? 0 times what? Sine of what? Theta. And this will still be what? 0. So then you have what? A times what? Cosine of what? Theta. That's how come I had the x over what? The theta to be equal to what? A cosine of what? Theta. So that was just by the way. Okay, so now that we found the x over what? The theta to be equal to what? A cosine of theta, let's make the x the subject. So I have what? I'll multiply the theta with what? A times what? Cosine of theta. So I have what? The x will be equal to what? A times cosine of what? Theta, the what? Theta. Okay, so this is what we have now. Okay, so now that we have this, okay, let's focus on what? Cosine theta. Okay, let's focus on what? Cosine of what? Theta. Okay, so I have what? Cosine of theta to be equal to what? Square root of what? A squared minus what? S squared over what? A. So what you are going to do here is that you are going to make the square root of what? A squared minus what? X squared what? The subject. So I can do that by just multiplying this side with what? A. So that what? Equal to what? A times what? Cosine of what? Theta should be equal to what? The square root of what? A squared what? Minus what? X squared. Okay, so now that you've gotten this equations here, okay, we can actually come and what finalize what or simplify what this question here. So let's look at that. So now you had what the question to be integral of what 1 over what the square root of what a squared minus what x squared, right, times what the x. So that what 1 over, the square root of what a squared minus what x squared. Now we find it to what a times what cosine of what theta. So now let's gonna write it here. That will be divided by what a times what cosine of what theta times what the x. And the x is now equals what a times what cosine of theta the theta. So that will be what a times what cosine of what theta the theta. Okay, so from here you can see that you can cancel out the a, you can cancel out cosine of what theta. Okay, so and then we have what the integral of what 1 the theta, which is the same as what the integral of what the theta, and this will give me theta out plus what c. Okay. Okay, so now that you've gotten this, okay, our question was given to us in terms of what x, so our final answer must also be what in terms of what x. So now let's come back to this side. We have sine theta equals what x over a, and from here you can make theta the subject very easily, right? So this will be the sine of what theta equals what x over what a, right? So theta will be equal to what the sine inverse of what x over what a. So you can actually substitute that here. So this will be equal to what the sine inverse of what x over what a plus what c. So this will be what our answer for such an expression. So if you want to take the integral of what such an expression or a function that involves what the square root of what a squared minus what x squared, this is the formula this is the approach that's what you are going to use to solve such problems. Okay, so now let's look at the second situation also. Okay, all right. Okay, so in that case, also let's say you want to find the integral of a function of the form 1 over square root of x squared minus what a squared dx. So you want to find the integral of what such a function. How are you going to do this? So you're going to apply the same method here as we did to the previous one. Okay, by drawing our triangle. Okay, so I have my triangle to be of this form. This is what theta. So I'm going to have this side to be a, and then this side to be what x, and then this side will be the square root of what x squared minus what a squared. So now let's write down equations for the sine, cosine, and then tangent of what the angle. Right, so we're applying SOHCAHTOA here. Okay, so the sine of the angle, that's sine of what theta what opposite over what hypotenuse, right? So that was x squared minus what a squared over what hypotenuse, so that's over x, and then cosine of what theta what adjacent over what hypotenuse, and then let me write this one, and then tangent of what theta what opposite over what adjacent, okay, over x, sorry, opposite over adjacent. The adjacent is what a rather. Okay, so this is what you have now. Okay, so at this part we are going to focus mainly on cosine and then tangent. Okay, let's focus on cosine and then tangent. Okay, so from here, from cosine equals what a over x squared, here you can see that what we can make x the subject very easily, right? So we have what cosine of what theta to be equal to what a over what x. So this will give me x times what cosine theta will be equal to what a. But I want to make x the subject, so I divide both sides by what cosine of what theta. Divide cosine of what theta. So this will give me x to be equal to what a over what cosine of what theta, which is the same as what x equals what a times what 1 over what cosine of what theta. But 1 over what cosine of what theta will give me what sec what theta. Okay, so I can actually kind of write this as x equals what a sec what theta. Okay, so now that you have x, what you would like to do now is what, to find the derivative of what x. Okay, so let's find the derivative of this. So that what, the x over what, the theta will be equal to what, a times what, the derivative of what, sec theta, which is what, sec theta tan what, theta. Okay, so now from here, let's make the x the subject. Okay, so let's make the x the subject. So let me come and we have some space here. Okay, so now we got what, the x over what, the theta to be equal to what, a sec theta tan of what, theta, right? So I want to make the x the subject, so that was the x will be equal to what, a sec theta tan of what, theta, the theta. Okay, all right, so this is what you have. So what we'll do next is that let's focus on what, tangent of what, theta. Okay, since it was part of the ones we selected, so we are going to focus on what, tangent of theta also. Okay, so now let's look at that. So tangent of theta equals what, square root of what, x squared minus what, a squared divided by what, a, right? But I want to make square root of what, x squared minus what, a squared the subject. Okay, so this will be equal to what, a times the tangent of what, theta equals what, square root of what, x squared minus what, a squared. So now that we've gotten these two, we are good to go. Okay, so we can now answer this question. So let's look at that now. So this will now be the integral of what, 1 over the square root of what, x squared what minus a squared, which is equal to what, a tangent of what, theta. So that will divide by what, 1 divided by what, a times what, the tangent of what, theta times what, the x. And you know the x is equal to what, a sec what, theta tan what, theta the theta. Okay, so this is what you have. So from here I can cancel out what, I can cancel out what, tangent of what, theta also. Okay, so then we'll have what, the integral of what, sec what, theta the what, theta. Okay, so this is what you have. But I know the integral of what, sec theta will be equal to what, the ln of what, sec what, theta plus what, tangent of what, theta plus what, c. But you know the question was given in terms of what, x, so our answer must also be what, in terms of what, x. So let's look at how you are going to do this. So let me first clear some space here. Okay, now let's continue. Now we have to do some substitution here. Okay, but already you know that what, the tan of theta equals what, square root of what, x squared minus what, a squared over what, over a. So that is already sorted out. But let's look at what, sec theta. How can you get sec theta? So for us to be able to get sec theta, let's look at what, cosine of theta. Okay, you know that what, cosine of theta equals what, a over what, x, right? So let's try and make x the subject. Okay, so x will be equal to what, a divided by what, cosine of what, theta, right? And you know this will be equal to what, a sec what, theta. Okay, all right, so now that you have what, x will be equal to what, a sec what, theta, let's divide by what, a, so that you can make sec theta the subject, right? So sec theta will be equal to what, x what, over a. So now you know that what, sec theta equals what, x over what, a. So now let's come back and then simplify our answer, or write our answer in terms of what, x. Okay, so now this will be equal to what, natural log of what, sec theta, which is what, x over what, a, plus what, tangent of what, theta, which is what, square root of what? S squared minus what? A squared over what? A plus C. Okay, so I can write this as what? The natural log of what? X plus what? Square root of what? X squared minus what? A squared over A plus what? C. Okay, so let's see how you can simplify this further. Okay, because our answers to looks a bit confusing, so let's simplify our answer. Okay, so now let's look at something here. When you have the log of, let's say, log of what? B over A. Okay, this will be equal to what? Log of B minus what? Log of what? A, right? So we are going to apply the same thing because the ln of what? Ln here is the same as what? Log. Okay, we are going to apply this here. That's the natural log of this expression here. So that what? Equal to what? Ln of what? The numerator, which is what? X plus what? Square root of what? S squared minus what? A squared, right? Minus what? Ln of what? A, right? Plus what? C1. Okay, let's make this what? C1. So now, looking at this negative ln A here and then plus C1 here. Okay, you see, since A is a constant, then negative ln A will also be what? A constant. So plus this C1 here, so they will all be what? A constant. So let's see, let's use the letter C here. So let's see capital C equals what? C1 minus what? The ln of what? A. So then we can represent what? Minus ln of A plus C1 with what? This capital C here. Okay, so let's see what our answer will be then. So our answer now becomes what? The ln of what? X plus what? Square root of what? Square root of X squared minus what? A squared plus what? Capital C. So this will be our answer. Okay, so now let's look at another situation where we will have to apply the method of what? Trig substitution. Okay, so let's say you've been asked to find the integral of the expression of the form, the integral of 1 over the square root of what? A squared plus what? S squared dx. Let's say you've been asked to find the integral of this. So let's look at how you're going to do this also. So I'm going to start by drawing my triangle here, which will help us do this very simple. So theta here. Okay, so in this case, I'm going to have my A to be here and then my X to be at this side. So this side what? A squared plus what? S squared. So let's write equations for the sine of the angle, the sine of the angle, the cosine of the angle, and then the tangent of what? The angle. So you are doing SOHCAHTOA. So you are applying SOHCAHTOA here. So for the sine of the angle, sine of theta, we got what? Opposite over what? Hypotenuse. That's over the square root of what? A squared plus what? S squared. And then cosine of the angle, we got what? Adjacent over what? Hypotenuse. That's over square root of what? A squared plus what? S squared. And then the tangent of the angle will be equal to what? Opposite over what? Adjacent. Okay, so here what you are going to do now is that let's focus on what? The cosine and then tangent of what? The angle. Okay, cosine and then tangent of what? The angle. Okay, so now what I'll do is that from tan theta equals what? X over A, I'm going to make what? X the subject. Okay, so that would what? Tangent of what? Theta equals what? X over what? A. But I want to make X the subject, so I'll multiply tangent by what? A. So that would A times what? The tangent of what? Theta should be equal to what? X. So I'll rewrite this as what? X equals what? A times what? The tangent of what? Theta. Okay, so now that I have x, I can find the derivative of what this expression here. Okay, so that what the x over what the theta will equal to what a times what the derivative of what tangent of what theta, which will be what sec squared what theta. Okay, so that was sec squared what theta. So now from here I'm going to make the x the subject. So that will be the x will be equal to what a times what sec squared what theta the theta. Okay, so this is what I have now. Okay, so from here the next thing you are going to focus on is what the cosine of what theta. Okay, so let's look at that one also. So we have what cosine of what theta to be equal to what a over what square root of a squared plus what x squared. Okay, so now what you are going to do here is that you are going to make what the square root of what a squared plus what x squared the subject. So we do that by multiplying it with what the cosine of theta, right? So we have what square root of what a squared plus what x squared times what cosine of what theta equals what a. So from here, I'm going to divide both sides by what cosine of what theta. Thereby what cosine of what theta. So this and this will cancel out. So let me kind of write what I have now. So now I'll come and have what the square root of what a squared plus what x squared to be equal to what a over what cosine of what theta. But I know this can be written as what a times what 1 over what cosine of what theta, and this will be equal to what a sec of what theta, because 1 over cosine of theta equals what sec theta. Okay, so now let's go and write this here. Okay, because of space, then write this here. So how about the square root of what a squared plus what x squared to be equal to what a sec what theta. Okay, so now that we have this, let's go and then answer our question finally. Now let's look at this. So now this is the question that was given. Okay, so I'm going to rewrite this. So this was the integral of what 1 divided by what the square root of what a squared plus what x squared. Then we now have down to what a sec theta. So let's write divided by what a sec of what theta times what the x. You know the x is now what equal to what a times what sec squared what theta the theta, right? So now you can cancel out a, you can cancel out sec, and then this also take out this. So then we have what the integral of what sec what theta the theta. But I know the integral of what sec theta will be equal to ln of what sec theta plus what tangent of what theta plus the constant what c. Okay, so this is what we have now. But I know since our answer was given to us in terms of what x, the solution to must be in terms of what x. So let's rewrite the solution so that it will be in terms of what x. So let's look at this. So now you can express our answer in terms of what x by making what some substitutions. Okay, so you can do that by making some substitutions. So from here you can see that what tan theta of x, tan theta equals what x over a, which is what I have here. Okay, so what of what sec theta. So we know that what tan theta equals what x over what over a. What of what sec theta. So let's look at what you have here. Okay, let's look at what you have here. So you have what the square root of what a squared plus what x squared to be equal to what a sec what theta, right? So you can divide both sides by what a, both sides by what a. So at the end I have what sec theta to be equal to what square root of what a squared plus what x squared over what a, right? Okay, so let me clean this and then rewrite it. So I have what sec theta to be equal to what square root of what a squared plus what x squared divided by what a. Okay, so now that we have this, let's substitute them into the final answer. So that will be equal to what the ln of what sec theta, which is what? Square root of a squared plus what? X squared over what? A, plus what? Tan theta, which is what? X over what? A, plus the constant. Let me make this constant C1. Okay, let me make this constant C1 for now. Okay, so now what will happen is that I'm going to simplify this expression that we have here. Okay, so let's see. Let's continue. So you see that what? I'll have something like this. I can write this as what? The ln of square root of what? A squared plus what? S squared plus X all over what? A plus what? C1. Okay, since they have a common denominator, I can write it in this form. Okay, so now what will actually happen here is that, when you have what? A log of the form log of what? B over A. This will be the same as what? Log of what? B minus what? Log of what? A. Okay, so it's the same thing that you are going to apply here. So you are taking what? The square root of what? A squared plus what? X squared plus X as what? B. And then you are taking A here as A. Okay, so let's look at that. So now I have something like this. This is equal to what? The ln of what? Root of, let me write this in a different color. Okay, so that will be the ln of root of a squared plus what? X squared, okay, plus X minus the ln of A plus what? C1. But I know since A is a constant and then C1 is also what? A constant. When you add these two, it should also be what? The answer should be what? A constant. So you see that what? Capital C, which is also a constant, equals what? C1 minus what? Natural log of what? A. That's the ln of it. The ln of what? A. So you can actually come and represent everything that we have here with what? Capital C. Okay, so I can actually come and clean this side here. Okay, I can clean this and then represent this with what? Plus C. Okay, so this will be our answer at the end.